Good morning, madam. Good morning.
Good morning, sir. Dhanlakshmi, Syed sir is here. Syed sir, good morning. Syed sir, good morning, sir. Very good morning, Meglingam sir. Ma'am has come, Chitra, HOD ma'am. She has joined her. No, ma'am. Good morning, Inetula sir. This is Dhanlakshmi.
Yeah.
Ma'am, good morning, ma'am. Ma'am, good morning, ma'am.
Good morning, Chitra. Good morning.
Good morning.
Ma'am,
Yes,
good morning, ma'am. This is Dhanlakshmi, ma'am. Yeah, good morning. Good morning. Good morning, sir. Dr. Ragadishwaran. Good morning, sir.
Good morning, madam. Very good
So
morning.
it was very nice of you for having given a consent to give us a talk. Thank you so much, sir.
It's my pleasure, madam.
Yes, yes, sir. Yeah. And thank you, Dr. Inayatullah.
Thank you, madam. Thank you,
sir, for being in this platform. It's nice having you here. What time is it, sir, in your place?
My play 11 o'clock, 11:50.
It's 11:15. Okay.
Yeah.
So you're way ahead of us.
Yes.
Yes. Thank you very much, sir, for being here.
Thank you.
Thank you, sir.
Good morning, Kannadasan.
Good morning, sir.
Good morning. Good morning.
Morning, தம்பி. கண்ணதாசன் எப்படி இருக்க? நல்லா இருக்கேன். எப்படி இருக்கீங்க? Fine, pa. I think now time is 7:38. It's okay. இன்னும் ஒரு 2 minutes நினைக்கிறேன். இல்ல விசிட் வந்தாச்சு.
Morning, Paul sir.
Good morning, Pragdishwaran. நல்லா இருக்கீங்களா?
நல்லா இருக்கோம் சார். நல்லா இருக்கீங்களா?
Very, very nice to see you. Congratulations on your promotion.
Thank you, sir. Thank you, sir.
We are proud of you. God bless you.
Thank you.
Chitra?
Yes, ma'am.
Chitra, I think we can start, Chitra.
Yes, ma'am. Yes, ma'am.
So you have already got 100 participants.
Yes, ma'am. Shall we start now?
Yeah. Now we will start.
Yes, ma'am. Yes.
So good morning to everyone and a very warm welcome to the webinar series on Animal Sciences 3. And today's webinar is on the sustenance of aquaculture practices via new technologies. And we are most happy to have two very good and renowned resource persons, Dr. Bragadishwaran, who is the Deputy Director of Research and Development and Associate Professor of CAS in Marine Biology from Coimbatore. And we are also happy to have Dr. Inayatullah Nayasuddin, who is the Operational Farm Manager from the Island Prawn Company, Jeddah, Saudi Arabia. It is my pleasure that the webinar series 3 is taking off in the note of having very good renowned speakers in the field of aquaculture. And those of us who are interested in aquaculture practices, I think there will be no better person than having Dr. Bragadishwaran from India and Dr. Inayatullah from Saudi Arabia. I'm sure you will take a lot of key factors back home and try to translate this into your own research. So we look forward to a very resourceful day with the resource persons and also a very resourceful day to all the participants who have very actively responded to our invitation. Okay, over to you now, Chitra.
Thank you, ma'am. Every day is new beginning, new strength, and new thoughts. A very good morning to everyone. On behalf of PG and Research Department of Zoology, Nirmala College for Women, I welcome you all for the webinar series on Animal Sciences 3. It's my pleasure to welcome our Secretary, Reverend Sister Dr. Ruby Alankara Mary, Principal, Reverend Sister Dr. Helen, Vice Principal, Dr. Sister Mary Fabiola, IKC Coordinator and Head of the Department of Zoology, Dr. Pauline Vasanthi Joseph, faculty from various departments, and my colleagues. I take great pride in welcoming all the learned professors, research scholars, student friends, and from my own college and from various institutions. I would like to extend my special welcome to our eminent speakers, Dr. Pragadishwaran sir and Dr. Inayatullah sir, for this webinar series on sustenance of aquaculture practices via new technologies. Once again, I welcome you all for this webinar. And the participants from India and from different countries, including Philippines, Dubai, Saudi Arabia, and Sri Lanka. Let us start the first session. The first session will be started by Dr. Pragadishwaran. Sir is currently promoted as Deputy Director of Research and Development, CAS Marine Biology, Parangipetai, Tamil Nadu. He's going to give a talk on the topic, improving the resilience of aquaculture and capacity of fisheries and economic development. Sir has 17 years of teaching and research experiences. He published more than 85 research papers in national and international journals, and he published 4 books. Sir guided 8 PhD and 9 MPhil scholars. 12 scholars are currently working under his guidance. He completed 3 major and 1 minor project, and he has 1 ongoing project. Such an eminent person is with us today. I welcome you, sir. Now the session is for you, sir.
First of all, I would like to thank the authority of Nirmala College, Principal Madam and Vice Principal, Head of the Department, Dr. Vasanthi, Madam and Chitra. I very particularly I thank my sister, the Dhalashmi, for giving me opportunity to be with your platform, Nirmala College webinar platform today. And also I thank my teacher Paul Jivanandam also in joining with us this along with this program, and I thank my junior friend Inayatullah for the next session for presentation. And before I going to present my this topic today. The aquaculture and fisheries, it is a very, it is next to the agriculture because India is bestowed with a biodiversity country, and we have very good resource for livelihood options and food security. When we are starting aquaculture not a, we can say the cultivation of animal in a controlled condition, that is called aquaculture. But in according to the FAO, they given a different kind of definition for cultivation, and the cultivation is very because we can target to improve the quality of culture and the quantity we expected. In 1990 and between 1990 and 2010, and that growth rate of annual growth rate of the culture, freshwater and marine aquaculture is about 7.8% worldwide. And we are in this growing phase that is called a developing country. Developing country, we need a lot of that's a food supplement for the population, because we are reaching that the top one population in the worldwide. So that we required that fishery product is 4.4 million tons per year, and then we have very recent data show that India is the second largest animal protein producing country next to China. We are looking forward to compete with the Chinese product, and when we started our that target is when after post independence India. There are a lot of pressure for our development sector, and then government of India started for 5-year plan, like 5-year plan, and they started green revolution, then white revolution and blue revolution. And through that we little bit reach our target area. In aquaculture and fisheries sector, the contribute major animal protein to the population. This slide show this different color pattern of the world map. It shows that. Hello.
Sir, sorry for the interruption. Please share your screen, sir. Yes, just share your screen, sir. Your screen is not visible, sir.
Now?
Yes, sir.
Now you got it?
No, sir. We can't see your screen.
Now?
No, you will share your screen. Better. You will share your screen.
Now you got it?
No, sir.
Sir, you can use that present now. Please use that present now for sharing your PPT.
Oh, sorry.
You can put your PPT on slideshow, sir. Then you can use present now. Yes, you're
Yes, sir.
presenting now.
Yes, sir. Yes, sir.
Okay, sorry for the inconvenience because I somewhere I stopped that because this when we talking about that Indian aquaculture and fisheries, we are started at the early 90s when that post independence started. The government plan for 5-year planning for a development of agriculture side and also that marine fishery development and. According to the FAO and other in India, we follow the EMBIDA definition for culture of marine and freshwater animal for that it is shows that 7.8 worldwide annual rate in worldwide in 1990 and between 1980 and 2000. And there is a need for the development. India produced million tons of fresh every year, and we estimated record estimate is for 4.1 million per day. And after the Second World, the whole entire world they are looking. They need to make a peace on development. And in this development sector, there are some collaboration. There is a mutual understanding between the nations. They extended their help to promote the peace and development for their societal development and hygienic and other aspects. And these slides show that the world map, it shows the different color. The color indicates that consumption of animal protein, that's per capita consumption of protein, and you can see in the India it is a very that's below 2 kg per year their consumption, and you can see the Norway, other country they are big. And another this graph shows this this aquaculture seafood expected to overtake by the aquaculture because now the aquaculture is very good boom in aquaculture. Originally it started in 70, but in 2004 that Indian candidates fish like Monodon and Indigas getting WSSP disease, so that culture become decline. Now we are using this Hawaii species, that is Leptopinus venami. We imported a species from Hawaii that we are quarantined at our station. Then now we are getting some booster. You can see the global share of aquaculture is fish production in 97 and focus for 2000. That actually that 31% of the global aquaculture is in 1999. You can see with 2020 that it is reversely it is occupied aquaculture. It is 68% of this production, and you can see this. The contribution of captured fisheries and also the aquaculture. The aquaculture, because earlier the people are depending for the wild catch. That is called captured fishery. Now it is turned to aquaculture. People are consuming, and also they are make use of this resource for consumption, human consumption. That equal to 50. Equally, they are coming to the share. That is 50% share. It is coming to the into the picture. And in India, we can see these different state. The contribution is inland fisheries, and also the marine landings. And we can see this last 5 years from 19 to 2030. The Andhra, West Bengal, Gujarat, Kerala, and Tamil Nadu, they are major contributors. In last 3 years, Gujarat is taking first place, but now this year the recent statistical data show that Tamil Nadu is taking placing to come the first level. And when we are talking about this aquaculture and fisheries development in India, we never neglected, we never forgot about this early stages of the Indian fishery development. It's called post-Indian fishery development. That is a main project. It is initiated in 1952 by 340. Originally, that is an Indo-Norwegian project that is called NIP. Indo-Norwegian project. It is the main intention to make the societal development and the sanitation and also the fishery product development. Actually, in 1952, October 17, the 5 parties MOU signed between Norway, India, and government of Trump. that time there is no division like in Kerala, Tamil Nadu, and Karnataka. There is a government of Trivandrum, government of India, and Norway. They started a tri-party agreement. That agreement is there. Promoting the fishery by way of technology by Norway. In after the second phase of Indo-Norwegian project, the tri-party is included. US is support for the funding, and Norway given a technology for Indian fishery sector. The main aim was to develop fishing industry and improve the living condition in the community in the west coast, mainly in that is near in Kollam, the Nindakara, the fishing village is taken a model village for improving this fishing method and increase the profit of the better utilization of fishes to improve the sanitation condition and the health of the population and improve the standards of the community in general. That the main target of because when you see that Indian fishing market, even now you can go to any landing center or fish market. Most of the fish market, they are located on the nearby the landing center. The landing centers are not properly cleaned and not hygienically. Because if you are seeing in a shoe shop or your garment shop, it's become very good air conditioned showroom. But you can see the meat shop, fish market, and vegetable market in India. You cannot step on near that area because too much of wastages are dumped and they are decayed and they can get more smell in that area. So the condition and then they want to improve the sanitary condition and also the health of the particular population, the fishing population. And when they are introduced when they are involved into the fishery, there are some developments are taken place in during this Indo-Norway fishery project. Originally, we are basically hunting fish hunters. We can hunt the fish with the traditional way by hand picking. Sometimes we can use stagnant water and also hooks and other things. And when this because we are not efficiently, we go for not went for any fishing, so that they are introducing some outboard fishing that they can use motorized catamarans and the coast canal to enter the sea for fishing. So that is a main that is called modern equipments are used for fishing. In the first phase start from 1953. It is called Technical Cooperation Agreement. That is originally they given a technical support to the fishermen, mainly Nindakara Fishing Landing Center. And this that is called Indo-Norway project. That's a INP project office is located in Kannur region. Then they after some time that they are extended the west coast in Kerala coast, Kannur to Kollam, and then after later they come to Ernakulam. That's now in the Kochi, and they supplied for the costly equipment, modern fishing vessel, a nylon net, a train fishing canning equipment, and fish meal plants and fishing hooks and diesel engines. And they given a series of large number of new equipment, fishery related processing and fishing technology equipment. They are supplied to Indian fishermen, and they started some research like the small research laboratory processing unit in Mangalore, in Karnataka, and Cochin in Ernakulam in Kerala. The second phase, and continuously the second phase was started in 1970. And during this phase, they are using this mechanized boat. That means the outboard motor. That is catamarans with the outboard motor. because they can go at least in 10 nautical miles from the shore for fishing. And during that second phase, the shrimp cultivation is started. The surplus shrimps started to export other countries. That is the main duration for the second phase. And third phase, in between that is 80 and 90. The rapid motorization of indigenous craft, and that is called outboard mode, and reduction of that is, and when their technology support for fishery, at the same time that some other side, the drawbacks also started for declining of resource. So the introduction of burning trawling on monsoon season, and also the passing by Kerala government for marine fishery regulation, that is called fishing holidays. When this fish holiday, it is now followed all the 7 states in India for the fishing schedule. During this, there are in this fishing holiday when we are introducing mainly for because this is small size juveniles are mostly they planning for a breeding season. They're mostly breeding season. Normally in India it is bestowed with the monsoons, that is a southwest and also northeast monsoon. When this southwest monsoon, post monsoon they are getting a lot of nutrients from this from the land source, because there are. But comparatively, the east and west coast, the productivity of the sea is west coast is more, because they're getting more nutrients from the landmass, like landmass, and also they're getting due to the current pattern of the west coast, that is called continental drifting, that is getting more nutrients from the bottom, and that is called upwelling. During the upwelling, that primary productivity also getting more, and that fishery resource, that is the fishing intensity is taking more and getting more fishing. But what will happen the next after post monsoon, and when they going for fishing, the decline of resource it indicating. So when what they understand that the government is making a policy to make some restriction for fishing, that is called fishing holidays. So why? Because then also they started for regulation of fishing net, that fishing nets mesh size and craft and type of mechanized boat, and time of duration, hull duration, and efficiency also they taking care of this during fishing holidays. This is the second phase they've and the Indo-Norway project to achieve more, because that is a fishing holiday. In 1990 and 2000, that's the fourth phase. It is a mainly globalization and impact. When we are in a global market for supplying, continuous supplying our product to the global. When we are signatory to the WTO, that is a World Trade Organization, then we need to go. We can go with their norms and everything. Whenever they because we are global, we are moving to global market. There are some regulation and other problem will be faced. Then the government they given subsidy to the fishermen, because sometimes they are not they are not reach the criteria. Then so the government is given the subsidy. And also it is a new opening for global market for fishery product, because earlier we are only looking for domestic market. Now we are main supplier for European Union, our aquaculture product to European Union. And when after then 2000 we are reaching this level. Then this Indo-Norwegian project, it is ended, but it will be taken care of the government of India. And when continue, we can see the growth, the early history of the Indian fisheries. The Indian Fishery Research Institute are the major manpower. There are technology. Their technology is transferred to the fishermen through this academic and research. In 1947, when the independence, before independence, the institute was established in Chennai. Others mean Madras in 3rd February. That is called Central Marine Fisheries. The original goal of the institute only taking survey, marine survey and marine fish landing survey in all the major landing centers. In India, the major problem at the post independence, the harbor is fishing harbor is very deep, it is a main problem. When that blue revolution started, then they started construction of a fishery harbor in most of the riverine mouth. They started to construct fishing harbor. So they fishing harbor they facilitate for all augmentation like refrigeration and landing and trawler berth and everything. It is they are provide a facility for in the fishing harbor. And this CM Para is shifted to Mandapam in 1949, and they started for the contribution is enormous, and they in fishery sector. And later this institute is shifted to Cochin and in Ernakulam in 1971. And the headquarters is in Cochin, and they have regional centers throughout the India in Chennai, Varaval, Mangalore, in Visakhapatnam. They are doing some, and now they are like slightly new to not only for making a survey, and they started research for a culture. They can do mariculture and other for other genetically improved. There is a modified GM genetically they are induced to some brooder, and they're getting some new traits and all. In 1964, the Indo-Norwegian Development Agency and also FAO, Food and Agriculture, they signed a contract to establish a national institute in Bombay that is called Fishery Research Institute. The main goal of this Fishery Institute for train the graduate. Now they provided a trainee for the fishery officer. Originally they are planned for original. But they are not provide any certificate and all things. Only they are given training, continuous training for the fishery official, like the state fisheries and central government fisheries in Bombay. This project is financed by the government of India and United Nations Special Fund. This is the become ICR Central Institute of Fishery Education. It is a deemed university. It is only fishery university in India. Their main role is supply of human resource to the fishery sector. They provide all master programs. They are having a master program and PhD, and also they are scientific people. They are giving technology, and also they are giving knowledge to the society. That means in 1972, the Indian Indo-Norway project was completely shifted to Ernakulam. And it is renamed the Indo-Norwegian project. It has become it's renamed. It's an integrated fishery project. Integrated fishery project. They mainly they are processing. They are mainly they are making expertise in this field of processing, and they are promoting and like canning, freezing, and other kind of product. They can make it. And once it is, the funding is stopped by Norway, then the Indian government is taken care of this institute, and the institute is renamed as the National Institute of Fishery and Post-Harvest Technology and Training. It is headed in Cochin. It is coming under the Ministry of Animal and Animal Welfare and Dairy. So. And this is the early stage of Indo-Norway project. And later, there is a Central Institute of Fishery Technology, a Central Institute of Fishery and Nautical Engineering, and ICI, Indian Council for Agriculture. That's called Indian Central Institute of Freshwater Aquaculture, and then Central Institute of Brackish Aquaculture, Chennai, and the State Fisheries College and Research. There's a large number of the agriculture university. They started fisheries college throughout the India. Now about 52 fisheries college in each state. In Tamil Nadu, very particularly in Tamil Nadu, there is Tamil Nadu Jayalalitha Fisheries University in Nagapattinam. They are having four major research sessions. Thuthukudi, Nagapattinam, and Ponneri and Talangairu. They started college, and similarly in Annamalai, we have the very good, it's a national reputed, very old marine biology station. We have in fisheries and non-fishery courses. This is the history, and when these research institute, they can provide technology and knowledge to the fishermen. Now we are getting the global position in third, in fisheries in third, in aquaculture second, and also with the GDP, the GDP 0.91% of GDP contribution in aquaculture sector, agriculture sector, and the per capita fish availability is now from 2 kg to 9 kg per capita, and total earning it is getting up 45 lakhs, 45,106 crores rupees of money flowing industry become industry, and that employment is contributing 190 millions they are contributing in this area. Because these it is possible only by the post Indian independence evaluation, that is contribution of Indo-Norway project or funding project. In 1972, the Ministry of Finance and Commerce, they started two major initiations. One is called APDA, that is another one is MPDA. MPDA Marine Product Development Authority, and also that APD Agriculture Product Development Authority. They started in 1972. They are mainly to encourage that exporting marine product, whether sometime in a raw or sometimes it is a process. The promotion of market promotion, capture fishery, cage culture fishery, and processing infrastructure, value addition, and quality control, research and development. Now that in Ministry of Finance and Commerce, the Ministry of Commerce Ministry, now they have own R&D. They started a center for Rajiv Gandhi Center for Aquaculture. They are doing a lot of research for in aquaculture aspect, like in mud crab culture and cobia, then lattice calcarifer. These are the things. These are the post Indian fishery developments, and recent technological innovations. There are a lot of society and agency are started by Government of India. There are about 429 fish farmer development agency, and also the fish farmer there's another 39 brackish water fish farm development agency was established for production of quality seed and also for essential quality seed production for the successful aquaculture. When we are talking about the second part of my presentation, aquaculture, that is in India, we are traditionally we are fishermen. We can collect we can get a animal from the wild catch at the early stage. That is called traditionally we are doing aquaculture like in a village pond or a small pool, something we can. People are doing this kind of aquaculture practice. When in late 70, aquaculture it is initiated in the form of a small farming that is called integrated farming, or like a traditional fish farming. In a traditional fish farming, the people are they are culturing like in a katla, murgal, other freshwater species. They are depending the wild. They collect the seeds from the wild not in much quality and also quantity, because the very lean number of seeds they collected from the wild, and they are a small pond. They are constructed a small pond without any specification and additional additional supportive equipment. They are pumped into the pond, and they introduce this wild catch seed. But they are not given any supplement feed for the growth. And this is one way. In some coastal states in India, after agriculture, after the agriculture, that is when paddy harvest, the empty land is used for fish culture. In in Kerala and West Bengal, very traditionally they are using this paddy field for fish culture. They are when the flood water or sometimes the riverine water, they can so when they open the sluice gate and getting inside, whatever the fish or crustaceans available in the water, they enter into the agriculture field. What will happen after some time? That all the straw are decomposed, and the decomposed material are used as a feed. These animals getting a small growth, and they are not achieve our target. But they, after some time, 3 months or 4 months, the next seasonal culture they started for fishing agriculture, they can harvest it. They are simply harvested, and they collected all the whatever numbers in this farm there in the paddy field they collected. In when the technology is developed, that hatchery technology, when the hatchery is started by that because that we originally in India that most of this Chinese hatchery introduced to India, they started for high density culture farming. Then we can use the number in a square feet will be increased for culturing, and also we are giving supplement feed and aeration and other technology to improve the quality of growth and also target achievement. It is called in traditionally we are not support any target. We are not expected to get more harvest. When we are mainly we are looking at intensive culture, that intensive and semi-intensive, extensive culture. We are increasing that stocking density and additional augmentations for improving the culture. That is a way we started our aquaculture. And later, in Central Marine Fisheries Institute and Central Brackish-water aquaculture, they started brackish-water aquaculture. When we are talking about freshwater fish, freshwater 90% is fish, freshwater fishes. In some places, the scampi, there is a macroscopium, rosenbergi, and malcolmsoni, they are also started. But when we are saying that profitable, we are not achieved that profitable aquaculture through this crustacean, like in freshwater micro, because the protein and that animal portion is very lesser than like when you compare with the marine, it is a huge amount. The wastage is very limited because the head portion is occupying a large quantity of the head is occupied in the body. So this is a problem. And the open sea culture is a technology developed by USA and Norway. That technology is applied in India, and this open sea culture, mainly that group, that is Ephinopilus malabaricus and Tavina, there are 2 species in India. They are started for mariculture, mariculture, and some places they started cobia cage. Cobia, it is a very good candidate species for marine sea culture techniques. And the major breakthrough is in aquaculture is the lobster farming. The lobster farming in a low saline. Normally the lobsters growing in higher saline and mostly they are associated with the coral reef and the sandy area. So the first time in India, National Institute of Ocean Technology and collaborate with Nirmala University Parangipate, we started lobster farming in low saline. The low saline means in brackish water in Estuarine area. Normally the salinity is between 14 to 25. That this is the first breakthrough. We started a lobster culture in a low saline, and normally lobster. That young ones we depend from the natural fishing. We are in contact with some people in Ennur Harbour, Ennur fishing area, and also Pondicherry. Below 100 gram, that's a 100 gram molded lobsters we are targeted, and we got this small size below the 100 gram lobsters we purchased from the Ennur and Pondicherry fishermen, and we started we can fabricated a new variety of a cage, that is a fiber that is called FRB cages. It is a designed by National Institute of Ocean Technology, National Institute of Ocean Technology, and it can float at the surface from the 1 meter depth. It can float. So mostly that we can walk above the cage. We can use to walk, and we can. There is a very good cage. It is easy to maintain in low, even very less depth water area. And it starts with when we are introducing this lobster 100 gram, after 3 months, that's after 90 days, it reached very good size. That means that we are not expected that much growth. We are given a small clam, that's Meritix and Metricasta, we are given for the supplement feed, and they are highly carnivores. They are even live shells they can broke and take it. And after this major breakthrough, this technology is given to some in Thoothukudi district. There's a Tarvegulam. There is a place in Tarvegulam. This technology we are given to the fishermen. Then now they have started for regular operation, and they are doing lobster farming in Tarvegulam villages. More than 4 family they are continuously doing this business. Now they are exporting to Singapore market. Every month through Trivandrum airport, they are sending live lobster to Singapore. In afterwards, we are trying with the Rajiv Gandhi Center for Aquaculture. That is a Ministry of Finance and Commerce. We started again. We have started with the Lattice calcarifer. The Lattice calcarifer cage culture, it is started in Parangipate, and the problem we faced is lot of disease. But compare with there is no disease in lobster, but cage Lattice we have not achieved that much for our experimental cage culture. But that growth is very good growth we are achieving that. And when we are talking about the Lattice calcarifer seed, their technology is they are doing hatchery. But in India, that sea bass, Indian sea bass or Lattice calcarifer hatchery technology developed by SIBA, that is a Central Institute of Brackish Aquaculture, by the leadership of Dr. A.R.T. Arasu. Their teams done an excellent job for the Lattice calcarifer, because the very difficult things to get young ones of lattice in a controlled condition. In this hatchery, that is normally in wild. It is a hermaphrodite perciform lattice calcarifer. When they're getting matured at the stage of fourth year, the female become into male. That is a main problem. But even though they are facing a lot of problem, that the SIBA he made a breakthrough for lattice calcarifer hatchery development. And afterwards, this technology, these seeds are given to local farmer in Nagapattinam, and they started. That is called crop rotation. That means culture rotation. First, for the summer, they started. They are doing pinnace monodon culture. And afterwards, after harvest, lattice introduced. So that it is reduced that the disease spreading, and also the farmer getting more but means because the lattice having more market value in India, local domestic market usage, because it is a very delicious and delicious that is called meat texture is very good compared with the other meat fishes. And next one is that mud crab fattening. The Rajiv Gandhi Center for Agriculture, and after tsunami, there are a lot of NGOs are coming to India for supporting the livelihood option for the local fishermen, because the local fishermen washed by the tsunami. But the government directly support to the that is called original fishermen. That means they are mainly they can go for fishing. But there are some allied associated family, they are depending the fishery, but they are not doing any fishery. But they are going for marketing, they are going for fishing along with the fishermen. So they are most of the government agency not worried about these people. So in some there is one agency from UK that the Shell Oil Company, that oil and the Shell Oil Company, they are coming to India, and also they provide the support for the non fisherman groups. They can give support, and they started for this mudcraft patterning in Sirgadi, and and now they're getting some regular income from that. And now the women self-group people, they are getting subsidy. That means a loan from the bankers, and they started for a very good mudcraft culture in it is in nearby mangrove backdrop. They are doing some this mudcraft patterning in Sirgadi and other places. And next one is that is called green mussel in India, having two the species. One is Perna verdis and Perna indica. The Perna indica, it is mainly available in the west coast of India from Gujarat to Kollam, and the Perna verdis, it is mostly in Kollam to even Sundarban up to Sundarban. These mussel, they are very good. They are supporting very good. They are supporting for supplement nutrients for the mussel meat, and also for shell factory, the calcium factory for the shell. And the culture of the mussel, it is a region from Calicut to Kasaragod and Kollam to Kanyakumari. This is a major mussel forming, the form of rock culture. But there are some hatchery technologies developed by CM4I, and they are demonstrated. But comparatively, the availability of the seed from the wild, that is called spat collection after monsoon in West Coast. They are collected the spat, and they are making 1 meter rope, cotton cotton mosquito net. It is made up of by hand stitching, and we can use this 15 to 20 millimeter small spat. The small spat are used, for culturing. After 3 to 4 months during before monsoon, probably they are harvested. It's a very good meat and shell supply to the fishermen. The main problem of this mussel farming is algal. That's called paralytic shellfish poisoning and DSP, dietary shellfish poisoning. Because these animals, these mussels are sedentary. They are not. They are mostly attached to the substrate because these are mycel threads. They can attach with any substrate. Then also their feeding is a filter feeding. Mostly they filter the water micro. They are filter feeding by algae, and then they can grow. There is a problem that is called algal bloom or a monospecies algal microalgae phytoplankton is dominated in a particular area. These mussels they consuming a lot. They are filtering a lot, and the toxins because then the lifespan of phytoplankton only 14 days. The datum. After that, they can release the pigment. The pigments is like they produce some toxic that is called dinoflagellate toxin and algal toxin. These toxin accumulated in the meat and the body of the mussel. There's a green mussel, and it is they have some problem when we are consuming this contaminated this. Bioaccumulated toxin contained mussel, we can consuming that it will create some problem. That's called paralytic shellfish poisoning. That paralytic shellfish poisoning means it will be due to that algal bloom. So there are some reports in Pondicherry and nearby southern part of Madras, Chennai coast. Regularly, this kind of problem is noted during summer because the people are local fishermen. They consuming the clam and meat. And very recently, we made our paper along with the Indian Institute of Medical Science and All India Institute of Medical Science and the Indian Medical Council. We are made our publication about this PSP and DSP from the molluscan. And when we are talking about this molluscan fishery, in the west coast, there are a very good river, Ramnad estuary and Astamunde estuary. They are very good resource for clam fisheries. Because this MSE, that's called Marine Stewardship Council, they recognized the fishery, that is a molluscan fishery, and they given certification. This is the only fishery is given certification by MSC in India because these black clam is export to Europe because the demand is more. So in India there are about 784 tons of clams annually exported to European Union and 500 tons from exclusively from the small estuary in Kerala. So this it is called new marine gold because throughout the year they are collecting these clams from the west coast, and this is a giant clam. Another than we can call it as a killer clam. It grows normally even sometime more than 2 meter, a meter of size. It is mostly available in Andaman area, and only in few countries they started for culturing this giant clam. That is called post-larval capture and culture. That means the spat collection. That means we can keep some like in a concrete tiles or something. We can hang out in this water column. That's called settle out. That means they can settle the spat, settle in the tiles, and we can collect the spat, and we started a settlement we can use as a young ones. But we are not giving any supplement feeding because the giant clam having a very good association with this symbiotic association with the algae. They produce a very fast growth with the symbiotic dinoflagellates. That's called microbial community structures along the meat. They can grow very fast. And but in ecologically, this is very critical when even when we are unknowingly step on that Tridacna maxima, Tridacna gigas, Tridacna cestosa. There are 3 species. Once a week, that clam is tightly closed in our legs, or when normally the underwater diver, scuba divers, they are very we can never steps on that because it is once closed. It is very difficult. It is killed. We can die. That's all. That's why it is called killer clam. That's a killer clam. We have reported this because this clam mostly associated with the coral area. But after tsunami, there's a live specimen we collected in Coimbatore coast, and it is reported in the Hindu paper. That is because this resource is now noted in some places in Lakshadweep and Gulf of Mannar. Some places they are noted. They are given some underwater divers are noted, and now they are getting some new distribution in coastal. That means coastal areas also. And that is another interesting feature. There is a echinodon fisheries, mainly sea cucumber. It is coming under the endangered species and scheduled animal. And India and the fisheries are stopped. That means regulated, and they are even some. We can see a regular appearance of news clipping in most of the local dailies and also in media, smuggling of the echinodons. That means sea cucumber. Sea cucumber smuggled from India to Sri Lanka and other nations like China. For example, you can 1 kg of dried sea cucumber around 50,000. You can imagine 15,000 dried cucumber. It is a very good medicinal value, and it is called as a beach steamer, and sometimes they used in medicine. I am in China. That's one place, Qingdao. It is a North China. There is a sea cucumber culture. They are cultivating this sea cucumber in a shallow rocky area. I witnessed that. I was sometime there. I noticed that they are culturing and they are using a market. They have a lot of market value. Sometimes they eat raw and processed like pickled and fried, and they can very good. There are lot of medicine, Chinese medicine. They are developed from sea cucumber. Then how we improve that? How this technology can improve the quality of aquaculture by the way. So there is a main genetically we can make use of cross hybridization and all the things, and that is called sex control or sex reversal. Sometimes and then in wild, that like in a group or lattice, they can change their sex during their lifespan. So that's a problem. Now why we worried about this sex control and sex reversal. The hormonal changes will influence to the body structure, body development. Okay? Because our intention is to develop that body content, that is a body portion. That is we can give a 1 kilogram of feed, convert at least to 1.5 gram of the meat. That is a FCR. The FCR is very important. We can get more body tissue part. So that is the main. Then some places are gifted. That means give tilapia, that is called genetically improved tilapia, that is called only male species. We can do the same crossbreeding from one F1 generation and F2, then we'll get all male or all female. That is kind of a technology that is called sex control. That is it is mainly it first started in US, and now that the CPTEC, that is the Philippines and other places, they are starting this kind of experimental studies. Now we are getting only male and only female. Likely they can get, that is called monosex culture. It is to getting prolific spawners continuously. We do that type of things, then we can get this kind of what is this monospecies culture. And mainly the same I already explained about this lattice culture for history of lattice culture hatchery technology by Indian Agriculture Research by SIBA, and mud crab by RGCA MBIDA, that is called Marine Product Development Authority. And the second one is another important is the disease management. The disease, when the WSCV noted spreaded in India from Bangladesh, West Bengal, and Orissa, Tamil Nadu, Kerala, Karnataka, and Gujarat, the Maharashtra and Gujarat, the whole entire coastal states is vanished by WSV, because the fishermen, the farmers are lost enormously, and also hatchery also they are lost their brooders due to the widespread syndrome. And the World Organization of Animal Health, that is called earlier from OIE, that is called International Office for Dice on episode, now that's OIE. They have some specific, they have some now they have given some criteria for the culture species, brooders, and also that fingerlings. That's called production of specific pathogen free. That's called SPF and SPR, resident, pathogen resident. That means to keep this animal for 2-3 years for the quarantine without any disease infection. That is the main intention. That is called SPF. That is once we are continuously, we can keep our species for a long time under the surveillance program. Then it will become tested negatively. Once it's negatively they reach, then they can give a SPF certified by the government certification for the farmer. The tested, it will be PCR test and ELISA and all the advanced technology are used for this disease diagnosis. And after WSP spread over in India, the aquaculture is getting down. In 2004, 80% of aqua farming systems are declined, and also the global market Indian contribution is getting low. And afterwards, and that non-native culture species like Leptoponis venami, formerly is called Penis venami. It is known as a Pacific white shrimp. It's called king crab, king prawn. It is we are imported from USA, and the brooders are we can export through Indian certified. That's an aquatic quarantine facility in Neelangarai, Patnapakam in Chennai by RGCA. That's our Rajiv Gandhi Center for Aquaculture. They certified. Once they certified, again it will be confirmed by Central List of Brackish Water. Then only that quarantined brooders will be given to the hatchery for seed production. And after the seed hatchery, the feed is very important, and because this it is because when we are doing this culture, feed is important. At the same time, we can give live feed and artificial feed. Live feed more probably they are at the early stage of culturing. We are depending live feed like Artemia, then Copipod, Rotifer. For this, we can give algae for the balanced and easy. That is for culture. And then in addition that the feed, we can give probiotics. Probiotics. The probiotics they are given very good. That is called supplementary feed to promote the growth without any industrial microbes, and also the balance to be optimize the genomal condition. That is the main intention for the live feed, and they can easily digest because they are live. And the formulated feed, there are two type of formulated feed. One is starter feed and then grow feed. The started feed, they are given number, different kind of number, and they can size differently. They are given size. At the early stage, that means up to 40 days, we can give starter feed, and then afterwards the growth feed. Because the starter feed are crumble and the growth feed are the pellet. There are some criteria when we are doing making of this formulated feed. There is some criteria for better survival, the health protection, and it will be scientifically formulated with all the ingredients like protein, carbohydrate, vitamin, minerals, and fat solubles, and everything is balanced from the natural source like marine and plant protein. And also it is high energy and it will be easily digestible by the animal. And there are some ethicals also ethical in the formulated feed. And normally the herbivores fish. Sometimes we culture herbivore fish. We can give. We can make the herbivore fish become like a vegetarian become to non-vegetarian. We can use the animal protein for making of this formulated feed. That animal become a non-vegetarian. So that is the things. It is things which we are doing for improving our kind of practice by adding animal protein. And how another interesting technology. We that aquaculture and fisheries. Aquaculture is supporting fisheries for getting economic, and at the other same time, we need to keep the resource for long usage, or we can because the sustainable utilization that we cannot over exploited natural resource for in a particular time. So there is another the same hatchery technology using for culture and also for resource management. So that is called sea ranching. When we are producing juveniles in a hatchery, then we release into the open. But in the sea grow or for in a natural improve the number of that means quality of resource by adding from the hatchery. It's called sea ranching. It is a very useful approach to increase overall landing, provide habitat, and for the adequate supply in future. It is a future, and also the regulation. We can make some regulation for fishing ban and all things. Very recently, there are regularly the government of, in particularly in Tamil Nadu and Kerala, they are doing hatchery. They are getting hatchery produced young ones and released into the natural system. In integrated courses on management phase 2 plan, there are about 80 million seats of Pinus monodon, black tiger shrimps, and 20 million seats of Pinus indicus, and 1 lakh seat of cobia. The total worth of 10.5 crores of rupees spent for sea ranching, in particularly Nagapattinam, Ramanathapuram, and Thuthukudi districts. That is a way we restore the depleted stock by enhancing through sea ranching, because there is two things we always we can keep in our mind for resource management and also sustainable utilization. When you are doing this balancedly, we can do. We can get. We can make this resource for in further. And there are some regulations. Then in India, not only India, worldwide there is some fishery regulation. In India, it is very peculiar because we have long coastal line and different kind of normal conditions. So rainy monsoon. So we have some regulation. The fishing ban and that's called. So in some places. Originally, the Kerala state fisheries they started in 80. They for fish Kerala Marine Fishery Regulation Act. It is an act they can started in 80. The same kind of act and amendments are followed by coastal states of India. Mainly, they intend to prohibit the use of dynamite. In the early stage of fishery, we are using. There is a dynamite for killing fish, and once the dynamite bombing, then the fish are dead and they can collect it. So what will happen is a non-targeted fishing. It is called a non-targeted fishing. So we can kill, we can damage the whole environment. So that is mainly they stopped the regulation. For sand fishery, clam and oyster, pearl oyster for license. You can see those days in the 80s up to 80s that Tuticorin means it is Tuticorin and Gulf of Kamba in Gujarat. These are two places are very good pearl fishery, pearl burns are. But now there is a single pearl oyster. There is a Pingata, Margatifera. There is a single species are not collected by recent observation. So that is a way that is the government of Tamil Nadu and then the government of India. They are giving some instruction to the fishermen, and they started for marine fishing regulations. And it is mainly this regulating the breeding. And control the mesh size, prevent that juvenile catch, and creation of close season during actual spawning time, and spread the fish stock among the many fishermen as possible. This is the way we can. But even some places that banned or regulated fishing, that's called fishing nets, are not allowed. But the fishermen, they can go for some kind of fishing, and there are some social problems are created among the fishermen between the villages. There is a regularly it is happen. We can make our resource to the. We need to preserve our resource. By nature, with the natural resource, we can make at least we can show our animal to the next generation. That is we can promote the aquaculture fisheries economics through aquaculture, and the same technology, the aquaculture hatchery technology, may utilize to restore our old stock, natural stock for the next generation. That is my conclusion. And I thank all the participants and presentation. My sincere thanks to Dr. Tanlakshmi, Dr. Chitra, Dr. Madam, Madam, and also I thank the administrative of Nirmala College, Coimbatore, for the wonderful opportunity for me to be a webinar presentation today. Once again, thank Dr. Tanlakshmi and Dr. Chitra, Madam. Thank you very much. If any query, please we can discuss.
Thank you, sir.
Thank you, madam.
Participants, you can ask your question directly to sir, or you can post your questions in the chat box in Google Meet as well as YouTube.
Sir, sir, can you hear me?
Yeah, this is Santanam from Bharatdasan University.
Welcome, sir.
Welcome, sir. Welcome, sir.
My compliments to Dr. S. Pragadiswaran
Thank you, senior. Thank you.
for his elaborative and informative lecture on aquaculture. And, thanks to the organizers for inviting Dr. Pragadiswaran, who has a wide knowledge on aquaculture. Why I am telling, he is a first person who started the lobster farming using brackish water. Normally, the lobster culture will be done in seawater, in the marine. This is a mariculture aspect. However, he has developed the technology and he proved the technology in Vellar estuary, where the brackish water exists. So the first time actually that technology was developed, and he came out with a very good result, which was later transferred to the RGCA and NIOT. So at this context, I should appreciate and congratulate Dr. Pragadiswaran for his effort and informative lecture, which will be highly useful for the participants, especially the budding scientists. Okay, so with this, once again I thank and appreciate an excellent and informative lecture delivered by Dr. Pragadiswaran. Now I move on to another participants, those who have queries.
Thank you, sir, Dr. Sandana. Thank you.
Thank you.
Thank you.
Sir, there is a question in the chat box session. Can I raise the question, sir?
Yeah, madam, please, madam.
Yes, sir. Actually, are there any adverse effects on the aquatic environment through cage culture? A question was asked by the person, are there any adverse effects on the aquatic environment through cage culture?
If it is in the confined environment, like in a lagoon or some low water area, that if less water exchange, that means very small inlets in like a lagoon. The cage, when we are using that excess feed or the unused feed will accumulated in the environment, and it will be created a problem. But in the case of open sea culture, there is there is no any harmful adverse effects on cage culture in the natural system. That's the main idea. But we feel we noted there is some kind of disease. There is ulcerative disease and some cannibalistic problem in cage culture during our lattice culture, culture in the brackish water. When we are demonstrated along with the Rajiv Gandhi Center for Aquaculture, there is some culture. That is the main problem is the supply of what is called feeding. That feeding we cannot achieve that our target. That's the main problem. But in the open sea culture, that there is no that kind of much adverse effect will not affect to the natural system. That's all, madam. We are only we face small incidents in cage culture, lobster, sea bass cage culture in Asian system.
Okay, sir. Thank you, sir. The next question, sir, by Mr. Praveen Prasad, sir. Inbreeding in hatchery and supply of seeds. Any rules from government to stop this type of activity?
No, actually, the government they are giving some promotion at the early stage. They promoted this kind of inbreeding and genetically modified. But now, due to that some exemption only, they're getting more profitable. On F2, F3 generation, the survival and growth is getting a problem. That's the main problem. but in first one or two F1, F2 generation is getting very good profitable. Then the growth is very good. And later, this kind of we continue the same that problem we are facing, that kind of problem. But now the government making some regulation for genetically, even like in a plant, there are some we are following some facing some problem. But at the early stages of for in Central Institute of Fishery Education and that's Central Institute of Freshwater Aquaculture in Bhubaneswar, they started for hybridization. Dr. Ayyappan, he is a director of when he is a director, he's given in he's done some kind of experiment like the genetic that mass breeding that's called all male and all female kind of things. But now government they started some regulation that is called a fishery the ICA they started. I mean the Indian Council for Agriculture Research. They the director of fishery education. They are making some regulation for genetically modified inbreeding. That's kind of thing.
So the next question is cryogenic seed fertilization, good or bad in carp fish?
It is good, madam, because when we are there is a main problem is seed transporting. That main we can transport the seed from far away to the culture area. That is a main problem. For example, in there is cold water hill areas on the Golden Marsher. In a Golden Marsher, only there is only one hatchery in Pune. Further, we cannot transport the seed from very long distance because in the cold water fishery we are depending seeds from one hatchery. So these cryopreservation techniques is more helpful to transport the germ plasma. That is mean the cells we can transport very easily to one hatchery to another hatchery, and also for avoiding that seed transportation mortality from. So that's the main. It is a very useful method for cryopreservation.
Thank you, sir. The next question. Which technique is proven efficient? Post-marine technique or present advanced technique? Which is economically best for small-scale fishermen?
We can go for current technology for improving because we now there are a lot of equipments facilitate for new to improve our aquaculture aspect, like an automated feeder, even we computerized feeding schedule, aeration, and also when the DO decline, it will be automated that aeration will be running at the early morning, because these all automated machines are coming, and the new technology will help that aquaculture cultural system.
Thank you, sir.
Thank you, sir.
Yeah.
Which is more preferred feed in aquaculture industry? The probiotic extracted from the gut or the commercial probiotic product?
But the gut only it is a more suitable, because it is we can go for natural. It is not a issue, but we can go for a gut microbial is very suitable, because it is they can easily digest that fiber or whatever the formulated feed that it can easily digest by these microbes. The gut microbes are more suitable for probiotic formulation.
Thank you, sir. The next question from Kaushik. Culture of economically important seaweed is good for marine ecosystem.
Yeah, actually.
Important seaweeds have negative impact on reef.
Yeah. Actually, in India, it's very concerned about this seaweed culture. We are originally that Ministry of Environment Forest is they have very good regulation before introduction of any non-native species to India. In that is called Kappa-Picus seaweeds are introduced from the Philippines to Gulf of Mannar biosphere during 2000. And in India, Pepsi and Co. They started culturing seaweed culture. Then early stage there is no problem, but now these Kappa-Picus is occupied in almost all the on the entire coast of Ramnapuram and the Thoothukudi area. So the problem is the fragmented seaweed thallus is easy to spread over due to that wind action and drifting by current, and that is it is occupying. It is a critical. It is a critical, and it is needed a policy. The government need to make a policy for introduction of non-native species into our environment. So because this we need to understand, and also long-term monitoring is very important for this kind of seaweed culture. But we can promote our native species for seaweed culture because it is a very good economic value and for getting it is another side of aquaculture. We can do seaweed culture, but we need to care non-native species introduction to our natural system. That's the main. It is a policy method. We need to take care of that.
Thank you, sir. Another question: are Indian major carps suitable for cage culture?
In Indian major carp, in most of the inland fisheries like in a lake and dams, there we are introducing, but cage is okay, but we cannot do in mass. That's the main problem.
So one more question: selenium nanoparticle is good for feed or not?
Now they are using a lot of minerals for making feed, but I don't know exactly the selenium for making a feed, and I don't know. I can say what is the usage of selenium very limited, but the minerals are something. Now the people are saying there are metals are used. Sometimes they may getting accumulation to the body and have some problem in next tropical level. I don't know. I cannot say perfectly selenium about the selenium in fishes.
Thank you, sir. The last question, sir. Pen culture in lagoon or open sea culture productivity, which is best, sir?
Pen, we can go in lagoon, madam. Lagoon.
All right. Any participants who would like to interact with Professor? You can unmute yourself and talk to Professor. Any more queries from the participants?
Yes, I have some query. Yes, sir. Very, very good presentation. Myself, Pravi. Sir, basically, I want to know that, currently, in fish culture or a prawn culture, we are using some immunology type of a thing so that the growth level increase in the fish as well as the shrimp. For the immunology, for the fish and shrimp, we have to go for the fermentation of the feed also currently with some minerals, vitamins, and other things. What do you feel this type of a content is good for this fish and this prawn culture, or some government rules and regulation on this or not?
Sir, now that for cage culture and pen culture, they are given some regulation in a lagoon or very for the estuary or backwater. In general, in aquaculture, we can do in estuarine water or something. we go for EEZ clearance and Coastal Aquaculture Authority in India. They have some regulation, but they are not much like in a cage culture or other type of culture, open sea culture. They cannot give any much because now they are promoting for this practice now, but not they're not given any legal advice to establishing this kind of proposal. But currently, they are given some note to the fisher nodal agency like in SIBA and RGCA and other nodal agency for making this culture.
Thank you, sir.
So one more question from the YouTube, sir.
Yeah.
Is it true that plastic is getting incorporated into mussels and oysters? Does plastic pollution have greater effect on marine organism?
Yeah, exactly. This is a very good question. This is the time to study in detail about the microplastic microplastic in animal, mainly the sedentary animal, because these animals are mostly in bottom. They are settled in the bottom, and they this microplastic, they are degraded microplastic. They are engulfed by this filter feeder. Sometimes even a paper published in Qingdao, in the first Institute of Oceanography in China, they published a paper, a small fragmented microplastic in the intestine. This paper is presented. So this is a the impact of microplastic in sedentary animals are very much, and we need to study in detail.
Thank you, sir.
Thank you, sir. Now we come to the end of the first session. I invite Dr. Vignesh Priya to propose a vote of thanks to Pragadiswaran, sir.
A graceful and warm morning to one and all present over here. I deem it a great honor and privilege to propose the vote of thanks in this webinar series in Animal Sciences 3. Sustenance of aquaculture practices via new technologies. On behalf of the Department of Zoology, I would like to thank our distinguished guest speaker, Dr. S. Pragadiswaran, Deputy Director of Research and Development, Associate Professor, CAS in Marine Biology, Parangipettai, Tamil Nadu. Sir, your lecture on improving resilience of aquaculture and capacity of fisheries and economic development. On whole, you provided us essential information for a betterment, understanding and monitoring and improvement of this aquaculture field. That fisheries and aquaculture play an important roles in providing food and income in many developing countries. And sir, you had given all the information and updation regarding aquaculture practices from the top to bottom, like current technologies, innovations, regulations, conservation, feed formulation, till disease management, etc. Sir, I'm sure that all the participants have taken note of your suggestions and would be helpful for their research conduct. So the way you explained the topic and clarified the queries for participants is exemplary. Once again, I'm thanking you very much, sir. Thank you, sir.
Thank you, Madam. First, I thank the management of Nirmala College, Principal Madam, Head of the Department, Dr. Sitra, then Dr. Vasanthi, and Dr. Dhalakshmi, my sister, for the invitation, and for all the participants. Once again, thank you all the participants.
Thank you, sir. Thanks a lot, sir.
Thank you, Madam.
Thank you, sir. Thank you so much, sir.
Thank you, Madam. Thank you so much.
Thank you.
Now we are moving to the second session of this webinar. I welcome our eminent speaker, Dr. Inayatullah Niazuddin, currently working as operational farm manager, Island Prawn Company, Saudi Arabia. Sir is the project in charge of more than 500 hectares of shrimp farming. Sir, having more than 21 years of experience in the aquaculture industry and wide knowledge on shrimp farming management, aquafeed industry, and all aquaculture inputs and outputs. Sir, providing international aquaculture consultant service and e-consultancy to aqua industry experts. He is also a panel valuer of private tank aquaculture projects. He received many awards and he is also holding the position of Chief Executive Officer in Shrimp Care Solutions, Nagapattinam, and Assistant General Manager in Sona Feeds, Pondicherry. Sir, welcome you, sir. We are waiting to listen your ideas and views on recent technologies in global aquaculture and in its development to fulfill human needs. Over to you, sir.
Yeah, thank you. Good morning, everyone. Thank you for giving this opportunity.
Thank you, sir.
Yeah. Yeah, come in.
So my screen is visible. My presentation is visible.
Sir, you are presenting, but your screen is not visible, sir.
Yeah.
ரைட் சைடுல டாப் கார்னர் லெஃப்ட் சைடுல ஒரு பிரசன்டேஷன் ஸ்லைடு இருக்கு, அதை கிளிக் பண்ணுங்க.
Sir, you are presenting, but your slides are not visible, sir. Open the PPT, sir. Yes, sir. Yes, we got it.
It's visible.
Yes, sir. Give the full screen, sir.
Yeah. Good.
Yes.
So okay, it's visible now.
Yes, sir. Visible, sir.
Yeah.
Sir, click the slideshow, sir.
Yeah. Wait. Yeah, I'll click the slideshow, but it show. Okay, I will start my presentation.
Yes, sir. Sir, give the from beginning first button, first key.
Sure. I have this. Which key? I don't know. Which
Left
key?
side first. Left side first, sir. From beginning. The slides are from beginning. And that line left side first button, sir. Left side. Yeah.
From beginning. Yeah.
Yes, sir. Okay. You can continue, sir.
Yeah. Good morning, everyone. Today we will discuss the recent technologies in global aquaculture, its development, and how fulfill the human needs. So first, what is the aquaculture means? It's a now present situation where we are having a more population in the world. So every country we are having we are producing the everything in agriculture only. But nowadays agriculture also slowly come down. So not that much of successful. So everyone having a protein requirement. That protein requirement we won't fill every human beings. So the World Health Organization will recommend to every human being need 8 kg of fishes. Fulfill the human protein needs, but that much of resources not available in all countries. So now, present situation, Indian government and every countries are concentrate and develop the blue revolutions. So actually, what is the aquaculture means? Aquaculture is controlled process of cultivate the aquatic organization, especially in human consumption. It is similar concept to agriculture, but with fish instead of plants and livestock. Aquaculture is also referred as a fish farming. The seafood that you find in a local grocery store likely labeled as farmed fish. The aquaculture can happen all over the world and does not, and it does in coastal ocean water and freshwater ponds and the river and even the land and tanks also. Now present situation, Indian government concentrate fully in the blue revolutions. What is the blue revolutions means? Already we are developed in the agriculture industry. That one is green revolution. Same parallelly we are developed in the white revolution also. Egg and milk, everything. That one is white revolution. Blue revolution is production through the water bodies. So now it's a freshwater, it's inland fisheries, inland water aquaculture, and brackish water aquaculture, sea open cage, lot of varieties in there in aquaculture activities. So Indian government fully concentrate in the blue revolution in upcoming years. Blue revolutions. The restricted central sector scheme on blue revolution called Integrated Development of Management Fisheries. Fishery sector with the special focus on new technologies while ensuring food and nutrition security to increase the development, empowerment, fisheries and aquaculture farmers. It also added the component of strengthened database and geographic information system for the sector. Though it various programs to the government enhanced the Indian's fish production 15 million metric ton by 2019 from the cultivation volume about the 10.7 metric ton. But we got the attention was here emphasis our government is involved with fisheries extension through the 477 Sagar Mitras and 500 fish farmers production organization. We hope to raise fisheries exports in 1 lakh metric ton in 2024 and 25. This farmer production organization is now developed. However, the expert in the field much depend on which one is made to this organization visible. So many opportunity available in the seafood sectors and aquaculture sectors. Opportunity available in government in the government sectors and private sectors also available lot of opportunities in India. This while adding the country export earning the earnings, it creates scope to fisheries and the fish farmers attain the target doubling their income. They are released by Agriculture Ministry said in February 2016, India's Prime Minister Narendra Modi announced that his government would double the income of farmers by 2022. Recently, Indian government announced the scheme of develop the seafood industry towards the blue revolution. In the Union Budget 2020, the Modi government made it clear it intends to promote the marine life. Finance Minister Nirmala Sitharaman in his budget speech referred to blue economy, and it said 2022-23 the government aims to raise the fish production reach to 200 lakh metric ton. It also focuses on growing not only for fishes, algae, seaweeds, and cage culture. So why is it important for the blue revolution and the seafoods? Giving the overfishing is our oceans and their natural resources country, increasing the area over. Human needs an alternate source of seafood fed the plant of the growing the population. So very much every human being needs a protein source. Without the protein source, we are having a nutritional deficiency. We are facing a lot of disease problem, health disabilities we are facing. So, most efficient, essentially needed in the protein sources. The aquaculture is the tool to fulfill the gap of seafood supply. The farming fish responsibility to the sustainability, the solution provides the future generation with access health environmental friendly protein options. So the aquaculture only having the high protein. See that protein levels here you mentioned that we are having fish is 31% protein level energy protein level is available. Compared to poultry 21%, piggery is 18, cow milk is 15%. So energy consumption, the fat, everything will be compared than other. The best source is seafood only, seafood and inland development fishes. So very important role play in the seafoods in human beings. The importance of aquaculture in India. Sustainable use of area source aquaculture system provides alternatives for fishing from the sea. And increasing the demand for food sources and increase the globalization has lead to increase in fishing. Aquaculture provides a both alternative and the opportunity for wild stock and replenish over time. The silent characters of aquaculture in India. High productivity when compared in agriculture or veterinary practice. Aquaculture is more productivity. Rural development, aquaculture mainly help to integrate the rural development by generating the employment opportunities and those help to arrest the exodus of the population in the rural urban areas. Intensive fish culture. In aquaculture, having the fish three-dimensional utilization of water body can be crowded more closely and the growth through the water circulation system. Approximately, it gives high yield about 25 tons per hectare per year. The scope of aquaculture to increase the production for per capita, consuming as per capita income, which national income will be higher. Ornamental purpose like culture of angelfish, black molly, red swordtail, blue garment. The type of ornamental fishes also to make the money and it's a small scale possible to run this type of units. Nutrition byproducts of fish like in glasses, clear essential fish liver oil, fish protein. The type of lot of byproducts we are using in the human consumption. So liver oil is a fish liver oil. Other thing, it's a very important play a role in the human being. Types of aquaculture in India. Based on the source, the aquaculture can be mainly classified in three categories. One is freshwater aquaculture, second one is brackish water aquaculture, third one is mariculture. The freshwater aquaculture. The freshwater aquaculture mainly deals with due to the culture of the urbanization freshwater source, namely rivers, streams, canals, reservoirs, and ponds, etc. The aspects of breeding of the parent stock growing the seed, preparing the water source of culture. Stocking, water management, post-stocking management, process and harvesting are included. Types of organisms cultured in the fish, prawns, mussels, and aquatic plants, etc. Freshwater fish farm consists mainly earthen ponds or basins and canals constructed from the concrete, where continuous water flow through is maintain his spring, stream, and other drainage water circulatory systems. There are a handful of fully recirculated aquaculture facilities that produce more than fishes with less water and less pollution. Closed facilities, and India is rich with inland freshwater fish with about 940 species well known from its rivers and lakes. Freshwater aquaculture to raising and breeding aquatic animals that are fish, shrimp, crab, and shellfish, etc. And also plants for economic purpose by the use of ponds, reservoir, lakes, and rivers, which play an important role in the aquaculture industry. Brackish water or coastal aquaculture. Brackish water aquaculture production is country largely accounted of the shrimp farming established by estanched without 123 million of recognized as a potential area for brackish water fish farming in the country of the total area. About the 10% as is being farmed at present. Of this area, about 80% under the traditional farming system and remaining under extensive farming and semi-extensive shrimp farming. The main activities shrimp farming and commercial scale and taken up the state Andhra Pradesh and Tamil Nadu. The traditional farming system are mainly located West Bengal and Kerala. Now also West Bengal and Kerala also now implement and enter the commercial activities. So that area also now promoted to the commercial activities shrimp farming. The commercial shrimp farming is more than a decade old in India, and both shrimp seed production and the farming practice based on technology imported mostly from Southeast Asian countries. The brackish water aquaculture, also called coastal aquaculture. The brackish water aquaculture, the brackish water and coastal fish such as mullet and milkfish and other sources will be cultured in here. The latter culture, the mullet, milkfish and shrimp, was tried to the state of Kerala and Tamil Nadu, Andhra Pradesh. Soil and water quality for brackish water and aquaculture is similar to freshwater aquaculture except for water salinity. The salinity responds for the quality of dissolved salt in given unit of water and generally expressed in gram per kg of water. So it's freshwater, compare the freshwater and saline water based on salinity only, depending upon the salt content of water. That based only will determine the species of culture. Culture species will be determined. Which species will possibly suitable for freshwater than brackish water. That only will decide the culture activities. Estuaries and backwater creeks and lagoons are major known to strengthen brackish water. These water fishes and sea milkfish, mullet and yellowes, maglops and polymus lattice, Heteroplus francis, tilapia, shrimp are affordable. The mariculture. The mariculture of fishes and other organisms, marine, brackish water, shallow base, and several aquaculture methods referred in mariculture. The culture mussels being done in some part of the country in Kerala and Karnataka. In this sea, the fish aggregating devices were created, which mainly refer to the artificial reefs. The organic and inorganic matter attack the biological organisms such as barnacles to fold these materials, which turn attracts small and big fishes. The marine culture, the tidal influence, wave actions, shallowness and turbidity, etc. are to be taken into the consideration to the structures and our cages, craft and may get washed off. This is the here a lot of species available there. So majorly we are culturing here Indian climatic condition. This is the Before that, we are having West Bengal and Kerala, Orissa area. Before that, cultured in Pune is Monodam, the tiger shrimp. So now all area will be completely changed. The American white leg shrimp, which is one of them. This is the major cultivable species in India. After that, inland fisheries, we are having fishes in important fishes. Fungus is sea bass. Sea bass is freshwater and salinity also both water will be cultured. The tilapia also freshwater and saline water is there. Then milkfish, crops, IFC, Indian major crop. This type of things majorly we are cultured in major occupation in freshwater aquaculture and brackish water aquaculture. Brackish water aquaculture species we cultured in the Litopinae, Manami, and mussels, green mussels and brown mussels, algae. This type of things we are cultured in the brackish water. So Pernavatis and Perna indica, the oysters, Japanese pearl oyster, the type of seaweeds we are cultured in brackish water. So Government of India helps the fisheries industries. The Government of India taken the several initiatives, the overall growth of development, fisheries and aquaculture in the country. The central and the state government should support the aquaculture production sector with an adequate policy framework. Preliminary steps to have made with the establishment of National Fisheries Development, the NFDB, and Marine Product Export Development Authority, NPDA, National Corporation Development Corporation, NCDC, with the National Federation of Fisheries Fishermen's Corporation, with overall 2.4 lakh fishing crafts and operating all the coast, 7 major fishing harbors and 75 minor fishing harbors, and 1,537 landing centers functioning the center of the needs for 4 million fisheries for promoting aquaculture. 429 fish farmers development agencies FDA, FFTA, and 39 brackish water fish farm development agencies BFDA were established in our country. The annual carp seed production to be turned the 40 billion fry and the shrimp about the 54 billion PLs, which increase the species diversification in the recent past. Besides the large scale of freshwater food fish culture, ornamental fish culture, and a high volume of marine fish farming and gaining the importance of the recent past. In the Union Budget 2020, the Blue Economy 2020 and 23 government raised the production 200 lakh tons. It is the target. The Blue Revolution, the Neat Kanti mission, has the vision to achieve the economic prosperity of the country, and the fish farmers well as contribute towards the nutritional security through the potential utilization of water resources, fisheries development and sustainable manner, keeping the view of the biosecurity environmental concerns. The NECOM missions will have multi-dimensional approach of activity concerned with the development of fisheries sectors, modern world-class industry in India. It will focus the tapping the food production potential, enhancing the productivity, sustainable from the aquaculture fisheries resources, both on inland and marine fisheries. Sustainability, increasing the share Indian fisheries, the export would be a key goal. It will ensure doubling the income the fisheries and fisherwomen, fish farmers, with the inclusive participation of the socio-economically weaker sections and ensure the sustainability of environmental and biosecurity. The governing regulation. What is some Indian government having some regulation to the every supposed to regulation and culture activities having a proper channel. They having a government bodies. Aquaculture activities will be controlled in the Coast Aquaculture Authority, will be monitored and controlled. Inspection, everything will be controlled in the Coast Aquaculture Authority. authority in India. So this is a act to maintain the Indian government. That's the into the century of old Indian fisheries that are active in 1897. Which panelists believe that fish by poisoning not as by explosive environmental pressure. Attacked in 1986, the being umbrella and containing the previous environmental level issues. They include the water prevention control commission in 1974, the wildlife protection, that one is 1974. Applied research and education and training. ICAR nodal agencies agriculture research in India has 8 fisheries research institutes. They are mainly responsible for research into the aquaculture, resource, SIPA, Central Institute of Freshwater Aquaculture, located in Bhubaneswar. SIPA, Central Institute of Brackish-water Aquaculture. It's located in Chennai. CMO for Central Marine Fisheries Research Institute in Cochin. Cochin having a mariculture also. Furthermore, the National Research Center's coldwater fisheries, bimatal concentrated with the coldwater fisheries in aquaculture. The following departments will follow the aquaculture activities of the research institutes. It's the Department of Animal Husbandry and Drying Fisheries, Fisheries Survey of India, Central Institute of Fisheries, Nautical and Engineering Training, National Institute of Fisheries, Post Harvest Technology and Training, Coastal Aquaculture Authority. All aquaculture activities will control the aquaculture authority. Even not culture hatchery, companies, having a feed company, medicine company, lot of companies in India. All system will be controlled by the National Fisheries Development Board, then Indian Council of Agriculture Research, Central Institute of Fisheries Education. There is a lot of institutions to support the Indian government for the development of agriculture. Aquaculture status in India current trends. Not only in India we having a not only but we are in second position worldwide. We are production wise we are number one position, but technology wise we are in the second position. But compare than the world India, we are doing almost 70% of the people now doing better
Ashwini ma'am, kindly please mute your audio ma'am. Ashwini ma'am. Ashwini Sendiladan.
Quality and traceability. Third one is future plans. We are deciding the next these topics. India seafood exposed against the global scenario. So we are towards the development. So after before that Pinay's monodon, the tiger shrimp, we having a minimum production. After once we introduce in India the Vanami species. After that, the production will be increased. Before that, tiger we are getting the only 2 to 3 metric tons per pound. After reaching the Lithopenes Vanami per pound, same pond we are getting the around 8 to 10 metric tons per pound. The production will be increased in 2008. This graph will be shown 2018. After that, we will reach the another part also. We now so 2020 we are the worldwide. We are the number one. India is the number one producer. Big country in China. China having a production, but not sufficient to the local consumption. Apart from the own use, China export from India some seafoods. So we are major contribution in vital role play in the seafood industry. So export also, so year by year increases. It shows this graph will be show 2018-19. It's 1920 also we are producing the more ships, and our most of the 95% we are export market also. So here Indian seafoods we are producing a lot of seafood, but consumption, local consumption is very less. But Indian people not get the awareness. Compared than other foods, the red meat, poultry and goat meat, red meat. Compared than seafood is having a lot of benefits and nutritional availability is there. So no awareness in Indian people. So once we will get the awareness, we will our local consumption will be increased. 95% we are the export the other countries. 80% we are export to the US market. This is the area wise Indian culture. The area wise this is the production and the total area. So now this is inland fisheries also, inland culture also developed. This figure will be increased. This is last year figure. This calculation will be increased, but day by day activities will be increased. The government also lot of moral support is given. So now this 2020 budget also lot of funds will be allotted to the blue revolution, that economy. So major once we come to the now 90% not only India. So every country having a Pinais Monami is the major production. So every country we having this is the procedure for step by step hatchery, then farming activities. Farming activities having a different types. One by one we will see. This is the hatchery operations method. This why so once we will get the animal male and female, it's a the white leg shrimp lies in the brackish water habits, matured or absorbed the. Meanwhile, the post larvae move to the inshore, spend their young life cycle. Mature subwater stages, coastal estuarine water, lagoon or mangroves grow in mangroves areas. Males attain the 20 gram. After maturation, the females attain 28 gram. The age of 6 to 7 months, Litopinus phenomenon weighing 30 to 45 grams. Will spawning 1 lakh to 2 lakh 50,000 eggs, approximately 0.22 mm diameter. Hatching occurs about 16 hours after spawning and fertilization. The term naplia means they can swim spasmodically and are absolutely in the phototake in the first larval stage. The next larval stage they feed in mysis and protozoan, and yearly post larvae following the phytoplankton and zooplankton. Meantime, they are passed towards the shore by tidal wave currents. The post larvae will change their plankton's habit for about 5 days. After molting, the feeding behavior will be changed. The moves towards the sea start the feeding and the benthic and diatal swamps and bivalves and the crustaceans. The Litopinus phenomenon growing in the extreme measurement. This is the post-larval production method. This is not actually. This type only will natural also. This hatchery also will produce. First, we will mating the male and female. Some stage we will get the eggs, that egg will be fertilized, then get the naplia, then mysis, zoea, that finally we will get the post larvae. The nursery system. This nursery system is a very vital role. This is one of the important role in aquaculture activities. So before that 90s, after 90s, we are facing the huge problem with the white spot symptom, the disease. After that, lot of difficult to survive and the industry is very slow development. Then we will implement the nursery system. The farmers suddenly become aware of the need to prevent the disease before the enter the farmer cycle. It is evident that healthy seed are kept in the good healthy harvest. What is the process? Before we are hatchery, we are getting the hatchery. It's PL 10 to 15. So 12 to 15 is suitable for the nursery system. We will maintain the tank, small system tank with high aeration, with good water quality. Everything will be having a systematic. We inoculate the PL 12 to 15. That is the suitable for the nursery system. Once we inoculated, we will feeding the high protein feed. Depending upon 2-3 stages, we are that feed will be dia is called the microns. That feed will be used. The maximum 30 days we maintain the nursery system. This 30 days we will give the full feed and the proper water quality and the full aeration. It will be reached 30 days in 1 gram average body weight. This is the main for the nursery system. This nursery system very sensitive to want to maintain the water quality parameters. Everything will be want to very careful want to do things everything. So basically, shrimp farming technologies in India and abroad also same things will be going on. Whatever we are following here in India, some technologies not possible to implement in India, depending upon the cost wise. We are having a wide area in culture activities. Some European countries are having some latest technologies. That technology having a infrastructure development cost is very high. That type of cost not implement in India. Reasons we are having a small farmers. That big corporate firms and big corporate companies develop that type of system. We will see the latter that what are the developments going on the aqua industry. This is the basic things. First one is the earthen pond. This is majorly we are doing the Indian farmers. Here still now we are in the 70 to 80% farmers using the earthen ponds one. Second one is the liner pond with the nursery system. This one is technology. It's a recent updated technology. But India, we are developing 30% farmers will develop this system. Next one is bioflux system. This one is bioflux system also using the natural source food with the flog, phytoplankton and zooplankton. That with the help of bacteria, beneficial bacterial strains. That will be feeding to the animals. Semi-bioflux system, first initial stage we are using the feed for natural source. After that we are using the artificial balanced diet food. That is the semi-bioflux system. The RAS-based system is so recently Indian countries we are having a lot of water scarcity. The system developed in Israel. First developed in Israel. Israel is first development. Then later every country will be that European countries also now doing the RAS system. RAS system means a very limited quantity water is enough. That water will be recycled again and again. So retreated and again used. That is the RAS system. The aquaponics is related to RAS. That RAS so wastewater will be released 5 to 10% from the released water, treated to through pipelines. That pipelines will inoculate the seeds, budding the agriculture that like vegetables, fruits, spinach, that type of things to grow. That waste animal fecal matter, everything will become the ammonia. That ammonia, the waste minerals will be take the plants. They develop that will be gaining the greenies. That system in the aquaponics. That one also it's now it's a recent development. Before that, not having that much of knowledge in the industry, but some activities before that going in Kerala area. Kerala people's doing the aquaponics. But now only recent trending all countries with the RAS system with aquaponics. Now all overseas countries and India also now develop slowly. This is the based on the actually criteria for the shrimp farm technology. For farming, we want to set the farming means want to the climate, tidal fed, that water quality, water source, everything will be that availability of feed and other things. Everything will be determined the shrimp farming and site selection. This is the earthen pond protocol. This is generally I will describe with figure photos, not elaborately. I will explain the thing. First, earthen ponds with the fully drying without water, full want to dry. Then scrapping. The scrapping before that we are doing the manpower. So now is manpower is very difficult to handle in the progress. So now use the latest equipments, the tractor, the blade use the tractors, that is remove the scrapping, then added to the liming. That soil pH, the maintain the soil pH, that purpose will be adding the lime. Then we are plowed with the tractors. Only with, 2 or 3 times want to plow the land, farmland. After that, we plan to start the pumping. The pumping, this is the feeder channel. Pumping to feeder channel, we are having a lot of three stages. We are using the filter mesh, the different size. To prevent the predators, fish, crab, like the eggs, that type of things not enter to the system, pond system. That reason only we are using the filter bags. After that, second next part is the biosecurity system. Yes, the biosecurity is the not bad person. It's involved in 4-5 activities. Major it's crop fencing and bird fencing. Bird fencing reason is we are Indian farming having a nearby here also. So abroad we are having the overseas. One pond to another pond having a gap to 100 kilometers. One side to another side having a gap in 100 kilometers. But now Indian condition not like that. So one farm with another next pond. It's nearby only that adjoin the coast river point and the backwater. We having a lot of farms linked. So the type of we are having a ponds. Any ponds affected with the white spot virus means immediately it's spread out by aerial contamination. So here aerial contamination is a very important thing. That time we are recommended to cover the bird fencing with the small nylon ropes, with cover the roof, like roof will cover. Once any problem, any disease problem we arrive, not possible to enter the animal, the birds will be cross contaminated the another parts. It will take the animal and throw the next pond. This way, it's another pond also will be next neighbor pond also affected the disease problem. That's why we are recommended that bird fencing. The next one is crab fencing. So surround the farming. We are put the mesh. Reason riverside onwards, some crabs will be entered to the pond. Crab is the white spot carrier. The WS is one of the carrier. So that one main is biosecurity, also very important factor in the shrimp farming activities. Once we will fill the water, it's a water culture. We want to put the aerators. It's a aerat filling. We want to select the seed selection. We want to select the PL 12 to 13 is the advisable for starting density. That time we will select the seed and give to the PCR. PCR will analyze the seed quality, machine gut ratio, and it's a development of organs. What is the activity of shrimp? So PL is healthy or not? That is the gut ratio. That is swollen and any diseases is there. That is we give the lab and get the report. Once 90% to 95% score seed only say plant to the starting. Below 80% or 70% seed will be rejected. Not possible, not advisable to start with mostly. This protocol strictly followed the farmers. Once we will start the farm, once hatchery to farm, we will try packing with different temperature in the hatchery. Our pond ecosystem having a different temperature and different salinity. So first we will take the seeds from hatchery. Bags will be inoculated in the pond water with half an hour. That time we having acclimatize the temperature. The water temperature will be first acclimatized. Next half an hour we will open the bag and sprinkle the water in the bag. Slowly that the salinity also will be acclimatized. Once this process will be completed, then we will start the pond. Animals will be released in the PLs will be released in the pond system. After that, we are first day to 30 DOC, we will put the blind feeding. It's mostly we are using the board feeding. Here, that's India, we are having the this type of bone field, but so overseas countries are having a big farms. Not possible to manpower control the everything. That overseas we are using the car we are fixing the machine. That machine we will put the feed means the feed will be thrown in the farm. So we are having 300-400 farms. We are having three or four vehicles. So one farm having a 10 minutes we will throw the feed. This is the feed machine that fits in a car. Apart than India and overseas, here ponds we are with small space only we get the bunks. Other area will be water spread area will use in the Indian farmers. But overseas we are using that every pond dike two cars will be possible to crossing. So everywhere inside the car and everything, what are the needs we will go to the inside. We are utilizing the feeding, the type of feeding. That aerators also, we are in aerators is the most important things the culture. So we are recommended to the 300 to 500 kg per 1 HB aerators. So depending upon the stocking density, we are on the aerator numbers. The efficient aerators, what are the source minimum? We want maintain the 5 ppm, 5 milligram per liter in DO level. So this one water quality and DO level also determine the animal culture. Then sampling. First after 40 days we are sampling the every 10 to 15 days. 10 days maximum. 10 days once we will put the cash net and collect the animal. We'll check the animal health. What are the feed intake? What is the gill is writer? That what any infection is there? We want to analyze the animal health checkup. Every week we will check the weighing also. That monitoring every week, every 10 to 15 days we have the 1.5 gram. We want the weight. Average body weight will be improved. That type of we are getting the average ADG, average daily growth and weekly growth. Then only possible to reach our period 120 days to reach the 25 gram to 30 gram. This is the way to monitoring of this. Any sufficient, any lacking is that means we will fulfill that lacking. This is the very important. Monitoring is very important. The things. So once 120 days to 140 days, depending upon the salinity and all parameters will be determined the culture of days. So mostly we are reached 120 to 145 days for the marketable size. After marketable size, we will harvest and selling. So this part we are having a water quality is more important. So every week, every 10 days once we'll give the analyze the water quality parameters and the microbial loads, everything will be in there. Once we are lacking any minerals, anything will be lacking in the water, we added the minerals additionally. Macro minerals, we added the supplement. Reason for this one is the closed system. So every animal day by day, so biomass will be increasing. Not sufficient to the minerals, water having not that much of minerals, animal will be consumed. Once the animal will be wanting in the shells, animals.
Ma'am, what happened?
I think so. Gone out.
Sir is gone out.
I think so.
What happened?
Nedula sir?
Inayatullah sir.
I think so.
Just hold on, Chitra. I'll just try to contact sir. Yeah.
Dear participants, sorry for the inconvenience.
Participants, please wait. Sir will join us within few minutes.
Please.
Dear participants, we are really sorry for the inconvenience. Sir will be joining us within 2 minutes. Kindly bear with us. Chitra ma'am, what's going on ma'am? Sir has joined or not?
She's trying, ma'am.
Okay.
Dhanlakshmi ma'am.
Yes, Chitra ma'am. Hello. Chitra ma'am.
Yes ma'am. Shall we wind up ma'am?
Let me have a word with sir ma'am. 1 minute.
Dear participants, kindly fill the feedback.
Dear participants, sorry for the inconvenience. Sir could not join us due to some technical problems. So I think we can wind up the session. Chitra ma'am. Chitra ma'am.
Ma'am, yes ma'am. We can wind up the session ma'am.
Yes ma'am.
Yes. Dhanlakshmi ma'am, you can continue.
Dear participants, a warm and graceful afternoon to our valid guests and participants. I give thanks to you, O Lord, my God, with my whole heart, and I will glorify your name forever. We are really very much owed to Almighty, the Omnipresent and the Omniscient, for providing this great opportunity in organizing the webinar series in Animal Science 1, 2, and 3 by the PG and Research Department of Zoology, Nirmala College for Women. It's my great privilege to propose the word of thanks on this occasion. At the outset, I would like to express my profound gratitude to the chief guest of the first day series, Dr. Hayano Avril, Dean of Sciences, Associate Professor in Zoology, Holy Cross College, Trichy, and Dr. S. Annie Jaya Christie, Deputy Director, Research Coordinator, Faculty of Medicine, Amherst University, Malaysia, for addressing the participants on exploration of biochemical and molecular perspectives in life sciences. Thankfulness is the beginning of gratitude. So on duty, and no duty is more urgent than that of returning thanks. I, on behalf of my own department, take this wonderful opportunity to thank Dr. P. Santanam, Associate Professor, Department of Marine Sciences, Bharatidasan University, Trichy, and Dr. Mitrai Lajos, Associate Professor, Department of Ichthyology and Hydrobiology, Faculty of Biology and Soil Sciences, St. Petersburg State University, Russia, who addressed the participants in the second webinar series about the theme Challenges of Water Resource Sustenance. I wholeheartedly thank them for sparing their valuable time in sharing their research experiences with us. Thank you, sir. Showing gratitude is one of the simplest yet most powerful things human can do for each other. I, on behalf of the entire organizing team, extend a very hearty thanks to the eminent speakers of the day, Dr. Bragadishwaran, Associate Professor, Deputy Director and Research and Development, Center for Marine Sciences, Annamala University, and Dr. Inayatullah Niasuddin, Operational Farm Manager, Island Prawn Company, Saudi Arabia, for gracing this webinar and sharing their knowledge, research finding, and experiences with us. I must mention my deep sense of appreciation to the speakers of the day for their explanation and briefing on the history and establishment of fishery research institutes and giving a bird's-eye view on funding agencies, recent technological innovation in aquaculture and marine species culture in brackish water, sex control and sex reversal technology, shrimp farming technology in India, water quality management procedures to be adopted at the farm level. Saying thank you is more than good manners. It is a good spirituality. I would like to express our profound gratitude to our Honorable Secretary, Reverend Sister Dr. Ruby Alangara Mary, our beloved Principal, Reverend Sister Dr. Helen, lovable Vice Principal, Reverend Sister Dr. Mary Fabiola, for their constant moral support and encouragement in organizing such programs. Since the essence of all the beautiful art is gratitude, I would like to acknowledge our gratitude to our motivated and dedicated head of the department and IQAC coordinator, Dr. Pauline Vasanthi Joseph, for her guidance and support in organizing this webinar series in animal sciences. I take this chance to thank all our beloved participants, faculty members who have joined us today from various universities and institutions, and also from various countries like Philippines, Dubai, Sri Lanka, Saudi Arabia, and so on, for their overwhelming support in making this webinar series a grand success. I'm happy to express my thanks to my dear colleagues for making this webinar program a grand success. I take this opportunity to thank my sister, Mrs. Nancy, and my dear brother, Dr. Dinesh Kumar, for their technical back-end support throughout the series. Without them, it would have not been possible and of a great success. Thanks a lot to one and all for their cordial cooperation rendered directly and indirectly in making this webinar series 1, 2, and 3 a grand success. I once again thank you all. And the feedback link is posted in the chat box of YouTube and also in the Google Meet. Kindly participants fill in the feedback. Chitra ma'am.
Yes, ma'am.
Can we wind up, ma'am?
Yes, ma'am. Yes, ma'am.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. Thank you so much.
Thank you, Syed sir. Thank you, Bragdishwaran sir. Thank you, Santanam sir, for joining us today.
Thank you, madam. My
Thank you, sir.
congratulations.
Thank you so much.
My congratulations
Thank you so
to
much,
you for
sir.
successfully organizing these 3 webinar series.
Thank you
I
for
wish you
all
all
your
the best.
blessings and support, sir.
Thank
Thank
you,
you so much, sir.
Thank you, madam. Thank you, madam. Wish you all the best.
Thank you, sir.
Thank you, sir. Thank you, Sandanam, sir. Thank you, Pragadishwaran, sir.
Megalingam, sir, thank you so much for joining us today. Thank you, dear participants. Kindly do fill in the feedback forms so that you can receive your certificates promptly. Thank you all the students, participants, and from various countries, and the faculty members from various institutions. Thank you so much. The questions which has been posted in the chat box will be sent to the professor and he'll answer you in person. Sorry for the inconvenience caused to you participants.
ஏமாப்பா போக மாட்டேங்குது எந்த குரூப்ல அதுல போட்டு இல்ல போக மாட்டேங்குது நான்சியும் போடுறான் போக மாட்டேங்குது
என்னது
ஃபீட்பேக்கு யூடியூப்ல என்ட்ரா போக முடிய மாட்டேங்குது அதை ட்ரை பண்ணுங்க இஸ் ட்ரைங் தி ஒரிஜினல் மெயில்
ஓகே ஹலோ
ஹலோ
எஸ் சார்
தனா மேம் தனா மேம்
எஸ் சார் போஸ்ட் பண்ண ட்ரை பண்ணிட்டு இருக்கோம் சார் ஜாயின் எஸ் சார்
இந்த புக்கை படிக்கும் போது
Chitra ma'am, she can post it.
Yes, ma'am. Yes, ma'am. It is
Yeah.
there in the YouTube. It is there. in
Yes,
YouTube.
yes. Thank you.
Thank you, ma'am.
Yes, Pa. Thank you so much, Pa.
Thank
We'll
you.
put the questions to Sir directly. Okay, the
Okay,
questions
okay,
in the
ma'am.
chat box, I've copied it. I'll post it to Sir in person.
Yes,
And
ma'am.
he may answer to the persons.
Okay, ma'am.